Hi, this video is for Unit 3 of Math 1001. It will cover topics related to right triangles. So I've drawn a right triangle below, and I will always designate my right triangle. So this angle looks 90 degrees, but I'll always designate it with a little square to show that it is in fact 90 degrees. A right triangle has some different parts that we want to make sure we talk about. First of all, it has what we call the legs, and those are the sides of the triangle that are adjacent to that right angle. And then the other one, which is the longer one, is always called the hypotenuse. Okay. When we talk about naming things on a right triangle, we're always going to name the side according to the angle it's opposite of. So we see here, this is angle A up here. So we are going to call the side opposite little a. Similarly, angle B down in the bottom right, the side opposite will be side B. And then our right angle, generally, we'll denote it with the capital C. The side across it is little c, the hypotenuse. Okay. One theorem that comes up a lot with right triangles that we want to make sure we're aware of is the Pythagorean theorem. And the Pythagorean theorem says that in a right triangle, a squared plus b squared will always equal c squared, which means take the length of one leg and square it, then add the length of the other leg squared. You will get the length of the hypotenuse squared. And it also says that if you have some triangle where that holds, where you take one side and square it, add another side and square it, and you get the third side squared, then you have a right triangle. So this Pythagorean theorem is helpful for us when we want to relate the sides of a triangle together, of a right triangle. So let's do a couple examples. A right triangle that we're given has legs of length 5 inches and 12 inches. What is the length of the hypotenuse? So first of all, let's draw us a right triangle. Okay, so there's my right triangle, and I'll denote it. Even though it doesn't look perfect, I'll put a little square right there to say, look, this is my right triangle. And its legs are length 5 inches and 12 inches. So this is not to scale, but that's okay. I just am drawing a little diagram. And so now I want my hypotenuse, which is my c value. Okay, well, I know that a squared plus b squared is c squared. And a and b, it doesn't really matter which one you call which, so we'll just call this a and this one b. I could have called them the other way, but this is fine. So that tells me that 5 squared plus 12 squared is c squared, or 25 plus 144 is c squared. Move up here. That tells me c squared is, and if I add those two together, I get 169. So if c squared is 169, I actually just want c. So I'll take the square root of both sides. So I can do second square root, see the square root here, on my calculator of 169, and that ends up being 13. So my hypotenuse is length 13. Okay? So now we have another right triangle. So let's draw another one. There we go. And we'll make it right by drawing the little square. It has one leg that's length 15 and another hypotenuse of length 20. So I know that this C is 20. That's my hypotenuse, is 20 feet. And one of them has a leg of length, or one of the legs is length 15 feet. So we'll just say B here is 15 feet. That means I need to figure out the other one. We'll just call it A. All right? So A squared plus b squared is c squared. So a squared plus 15 squared is 20 squared. I'm just plugging in that b and c. So a squared, if I square 15, 15 times 15 is 225. And if I square 20, that's 400. I'll subtract this 225 from both sides. And I get that a squared is, when I do that subtraction, I get 175, and I'll just kind of bring this back up here. a squared is 175. But I don't want a squared, I want a, so I'll take the square root of both sides. So let's do the square root of 175. So this is an approximate answer, so I'm going to erase this and say a is approximately 13.2. Okay, I guess I could also say a is the square root of 175. So this is my exact answer, and this is my approximation. And this one's approximate because I rounded it off. Okay, we'll now move on and discuss the idea of trigonometric ratios. These are just special ratios that we have defined in right triangles that show up a lot, that are consistent and help us talk about right triangles. So you may have heard of these before. We have sine, cosine, and tangent. The sine of an angle A, so from this one, our point of view is A. So pretend you're standing right there at A looking out over the triangle. Okay. The sine of an angle is always the length of the opposite side divided by the length of the hypotenuse. So opposite over hypotenuse, we can think opposite over hypotenuse, that's A over C. So the sine of A is the opposite over the hypotenuse. Okay. The cosine is another special ratio. The cosine is always going to be the length of the side that is adjacent to the angle we're talking about divided by the hypotenuse. We can kind of think in shorthand, adjacent over hypotenuse. That is B over C. And then our tangent of angle A is going to be the length of the opposite side over the length of the adjacent side. So opposite over adjacent, A over B. Opposite over adjacent. Okay, now these are all from the point of view of angle A. We could also think about the things from the point of view of angle B. All right, if we're looking from angle B's point of view, the sine of B, well, sine is still opposite over hypotenuse. Sine is always opposite over hypotenuse. So from B's point of view, opposite over hypotenuse is B over C. Oop, I copy pasted and forgot to change that, didn't I? Okay. So now from the point of view of angle B, our cosine of angle B is our adjacent over hypotenuse. Adjacent over hypotenuse. I bet this is going to be wrong again because I think I copy pasted and forgot to change that part. So adjacent over hypotenuse is A over C. And yeah, copy paste got me, so let's change that. And then the last one, the tangent, this one's probably going to be wrong too. So opposite over adjacent, opposite over adjacent. From the point of view of angle B, opposite over adjacent is B over A. Yep, copy paste got me. So let's just fix that up. So sorry about that, my bad. Shouldn't copy paste without checking all my work a little bit better. Okay, so these ratios are going to help us solve some problems. So let's look at this one. First of all, let's just find the sine, cosine, and tangent of angle A and angle B here to make sure that we know how to find all of these. So I'm going to make a little pattern here. So I need sine of A, cosine of A, and tangent of A. So you may have learned before, a lot of people learned SOHCAHTOA to help them keep up with everything. So if you haven't learned this before, the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So if you remember SOHCAHTOA, you can remember what order they go in. All right, so sine is opposite over hypotenuse, and I want the sine of A. So I'm right here at A, kind of like these are in blue to help me kind of remember my point of view. So from A, my opposite is 12 and my hypotenuse is 13. So this will be 12 over 13. All right, the cosine is adjacent over hypotenuse. So from this point of view, 5 centimeters is my adjacent leg, over 13 centimeters is my hypotenuse. So 5 over 13. And then tangent is opposite over adjacent. So from the point of view of A, opposite is 12, adjacent is 5. So 12 over 5. All right, so now let's do everything from the point of view of point B, or angle B. So sine of B, cosine of B, and tangent of B. And we'll let B be green. So all of these are the point of view of the green angle of angle B. So from their point of view, sine is opposite over hypotenuse. So from this point of view, opposite is 5 and hypotenuse is 13. So 5 over 13. Cosine is adjacent over hypotenuse. This one is adjacent, so 12 over hypotenuse 13. And tangent of B is the opposite over the adjacent. So from this point of view, opposite over adjacent is 5 over 12. So you may notice some patterns here. One of them has the sine, that's the other one's cosine. These match to one sine is the other one's cosine. And these are just flipped of each other. Because what did we do? From this one's point of view, this is adjacent and this is opposite. But from B's point of view, this is adjacent and this one is opposite. So basically all we did was switch the roles of all the opposites and the adjacents. And that made our different sines, cosines, and tangents. Okay, so let's do another example. So let's do an example of kind of a real world problem situation. So Jake has a 25-foot ladder that he's going to lean against his apartment building. So let's kind of draw, maybe that's the side of the apartment building, there's the street. And he's going to lean a 25-foot ladder, so that's 25 feet, against the building. The angle between the ground and the base of the ladder, so that's right here, this angle between the ground and the base of the ladder, we know is 70 degrees. It says, at what height does the ladder touch the side of the building? So we want to know, okay, well, here's where it touches. What height is that? Which means we need to know what is that distance. So this is our question mark. So notice what's happened. We've created a right triangle, assuming that the building hits at a right angle to the ground, which it probably does. Oh, there comes my picture. Sorry about that. The picture didn't come up. So again, just real quick, my 25-foot ladder, 70 degrees with the ground, the ladder and the ground, and it hits at some height, and we want to know that height. Okay, so how can we figure this out? Well, this is definitely the angle I'm going to sort of pay attention to do down here. This is sort of my point of view. And from this angle's point of view, I know the hypotenuse, and I need the opposite. So what trig value, or trig ratio, what trig ratio has to do with an opposite and a hypotenuse? Well, that's the sine, right? The sine of an angle, we'll say that some angle A, sine of A is always opposite over hypotenuse. So that tells me that the sine of 70 degrees is the opposite, we'll just call this x, over the hypotenuse. And I know what my hypotenuse is. They gave it to me. It's 25. So what am I doing? I just need to solve this for x. So to solve for x, I'm going to multiply both sides first by 25. And why would I do that? Well, multiplying by 25 cancels this here and here. And I'm left with just an x over on the right-hand side and 25 times the sine of 70 degrees on the left-hand side. All right, so I can actually just enter that in my calculator, just like that. Before I do it, though, I want to check one thing. I'm using degrees here, so I want to make sure that my calculator knows I'm using degrees. And I look at mine, it's telling me radians, so I need to switch it over. So I'll go to mode, right up here, click on mode, and you're going to go down, make sure radian is not highlighted, go over to degree, and click enter. So now your calculator knows you're entering things in degrees. So I can do second quit to get back to my page. And so I'll do 25 times the sine of 70 degrees. My sine button is right here, sine 70. And I'll close my parentheses, and it knows it's degrees because I changed it to degree mode. And I get 23.49. It says round to the nearest tenth, so I'll say 23.5. And my answer is in feet because I'm dealing with feet. It's this distance is what I'm dealing with, this distance. And since this was in feet, and I use that in my formula, this will be in feet as well. So that ladder hits 23.5 feet up the building. All right, so let's do another one. So now Amy is doing the same thing. She's going to lean a 25-foot ladder against the building as well. So here's her 25-foot ladder leaning against the building. And it's at the base of a window. So here's like some window up here that is 20 feet off the ground. So this distance is 20 feet. And we've got a right angle here. Now it says, what angle does the base of the ladder make with the ground? Well, here's my base of the ladder. So now I want to know what angle is that? Okay. Well, let's see kind of what we have. So I have some angle, and what do I have compared to it? Well, I have the hypotenuse of the triangle, and I have the opposite side, right? This would be adjacent. I don't have it. I have the opposite side. So I have an opposite and a hypotenuse. The trig ratio I should use is a sine. I have an opposite. So the sine of an angle is always the opposite over the hypotenuse. So in this case, the sine of, well, I don't know the angle, should be the opposite, 20, over the hypotenuse, 25. All right, so now we need a way to solve for the sine of the angle. We have that the sine of it is 20 over 25. I sort of need to undo the sine function. Well, the way I'm going to undo a sine function is the inverse sine function. So if you look at your calculator, right above the sine button, do you see how it says sine to the -1? That means inverse sine. Okay, so what I'm going to do is I'm going to take the inverse sine of this side. I'm going to do inverse side of that 20 over 25, and that will get me the angle I need. So inverse sine of the 20 divided by 25, and that'll get what I need, 53.1 degrees. Okay, so kind of the idea here is to undo it over here, I will take the inverse sine. So I'm going to take the inverse sine of this side as well. I took the inverse sine to clear this out. I guess I really should have just done that as an A. I take the inverse sine and just have an A left over. And I have to take the inverse sine of that side. And I'm left with 53.1 degrees. All right, let's do one more example with these right triangles. Okay, the next thing we're going to do is called solving a right triangle. To solve a right triangle means find the lengths of all the sides, find the measures of all the angles. Okay, so if I'm thinking about that, kind of my goal, I need I need angle A, I need angle B, and I need angle C. So I need to fill in all of these, and I need the length of side A, the length of side B, and the length of side C. I need to fill in all 6 of these blanks. Okay, before I get started, I already have some of these. Right away, I know it's a right triangle, and C is my right angle. So without much work, that's 90 degrees. Okay. What else do I have? I have that this side is 55 inches. It is across from angle B. That means little b is 55 inches. And here I have that the hypotenuse is 84 inches. It's across from angle C, so little c is 84 inches. So to solve this triangle, I need to figure out angle A, I need to figure out angle B, and I need to figure out side A. All right, so let's begin with angle A. Okay, so how could we figure out angle A? Well, what do I know? If I'm here at angle A from this angle's perspective, I have an adjacent length and I have a hypotenuse. Adjacent, hypotenuse. That's a cosine. Remember SOHCAHTOA, AH, adjacent hypotenuse has to do with cosine. So I know that the cosine of angle A is 55 over 84. And so this is like what we solved just a minute ago. I need to undo the cosine function. I undo a cosine with an inverse cosine. So what this tells me is I can take the inverse cosine of that number, 55 over 84, and I get inverse cosine of 55 over 84, and I get 49.1. We'll just do one decimal place. So 49.1, and that's degrees, okay? That's saying that angle A is 49.1 degrees. So I just found that, 49.1 degrees, okay? Remember kind of the idea, if I take the inverse cosine, I'm actually finding the angle measurement, okay? All right, so there's angle A. Now angle B, we could do this a couple different ways. First of all, I know that all three angles should sum to 180. So if I take 180, subtract 90, and subtract 49.1, I should get the answer. So 180 minus 90 minus 49.1. So it should be 40.9 degrees. So 180 minus 90 degrees minus 49.1. That's that 40.9 degrees. But I could have also set up a trig ratio as well here. So from the point of angle B, I have an opposite and a hypotenuse. Opposite hypotenuse, that's a sine situation. So the sine of angle B is 55 over 84, which means I can say the inverse sine of 55 over 84 to find the measure of the angle. So I'll do second sine to get inverse sine, 55 divided by 84. And what do I think my answer should be? Well, the other way I figured it out, I got 40.9 degrees, so I should get the same thing here. So let's see. Yes, 40.9. Now I rounded before, so this would be rounded, but I am getting that same answer. So I can feel pretty confident about it. I got it the same way both ways. So 40.9 degrees. All right. The last thing I have to find out is little a, and I can figure out little a. It's the side of a triangle where I have the other two, so I can use the Pythagorean theorem. So little a, well, I know that a squared plus b squared is c squared. So a squared plus, now b squared is 55 inches, or b is 55, so b squared equals c squared. So 84 squared. Okay. So this is a squared plus, let's see, what's 55 squared? 55 squared is 3,025 equals 84 squared. Let's figure that out real quick. 7,056. So I need to subtract the 3,025 from both sides. And that tells me that a squared equals, so 7,056. I can just do minus 3,025. That subtracts from like the most recent answer I got. And I get that a squared is 4,031. But I want a, so let's take the square root. Second square root 4,031. And I'll round this to 1 decimal place. So this is about 63.5. So we'll come back over here, 63.5, and I'll put my units. It's in inches. So there we go. We have solved the triangle. Again, solving a triangle means finding all 3 angles and the length of all 3 sides.